Welcome to Experiment 3 Implementation of MLP for Non-Linearly Separable Data. In this presentation, we will explore the use of multi-layer perception or MLP to address the challenges posed by the data that cannot be separated linearly. Let, let's dive into the details, starting with the objective of this experiment. The primary objective of this experiment is to implement an MLP effectively classify non-linearly separable data. Non-linearly separable data refers to data point that cannot be divided into distinct classes using a straight line by using an MLP, which is typical artificial neural network. We aim to understand how it can learn and model complex patterns to achieve accurate classification. Now let's move on to the program implementation. To start, we use a popular machine learning framework such as TensorFlow or PyTorch. Our MLP consists of input layer, multi-hidden layer with an activation function like ReLU and an output layer with a softmax activation for classification. We begin by importing necessary libraries and preparing our dataset for this experiment. We will use a well-known dataset like XOR problem, which is classic example of non-linearly separable data. Next, we define our MLP architecture. For instance, we might use an input layer with two neurons, one for each feature, two hidden layer with four neurons, and an output layer with two neurons. We compile the model with loss function like categorical cross entropy and an optimizer such as Adam. Upon defining the model, we train it using our dataset. The training process involves feeding the data through the network, adjusting the weights using backpropagation, and minimizing the loss function over several once training is complete, we evaluate the model performance on a test set. The results are typically visualized using a confusion matrix and an accuracy score. In our environment, the MLP successfully classifies the XOR data, demonstrating its abilities to handle non-linearly separable data. The successful implementation of an MLP has broad application. MLP are widely used in various fields, including image recognition, natural language processing, financial forecasting, healthcare. By learning complex patterns, MLPs are powerful tools for solving problems where linear models fall short. In conclusion, this experiment demonstrates the effectiveness of a multi-layer perception in handling the non-linear separable data. By leveraging the architecture and training algorithm, an MLP can learn with patterns and provide accurate classification across various applications. Thank you.